Hey guys, I'm just going to be here today to give you a little bit of hand with the nasty method of joints. So you see it, you think, oh dear, oh god, it's the method of joints. It's a pretty nasty method, but it's not that bad. I mean, it's definitely not as bad as the T results in maths. Well, that's a whole nother thing. Anyway, works off the whole idea that if a system's in equilibrium, then each member in the system has to be in equilibrium as well. So we can just calculate the forces in each member of the system. So, consider this structure. We've got a 500 Newton force up here, and our first step is to draw on the reactions here and here. But this reaction here, we'll know, is not a squiggly one, it's vertical from the 3-force rule. Then we have to make a free body diagram of that. And these two forces here, we need to know them, that's important as well. And just from that, for equilibrium, sum of the forces vertical has to be equal to naught, so those two will each be equal at 250 newtons, because that's an isosceles triangle. So, free body diagram is going to look like this. We put the big dots here, here, and here, so we can just see that that is a joint, that's a joint, and that's a joint. Now we want to label all these joints in the areas. A, B, C, D, then joint 1, joint 2, and joint 3. And now we have to analyze each member with their own personal free body diagram. That's just here. Now we have to draw a force diagram for each joint to calculate the force in each member. This can be a little bit confusing. So how we do this is, we first draw the force of everything we know. This one goes here, and that'll be AB in there. Then we draw the next one, doesn't matter which now, BD, then AD. And now, just like you would in maths, we can label this A, B, C. So that's a triangle ABC there. And if we look back at our free body diagram before, we can see that AD, that member there, is that line there. And so on. So now for our force diagrams, just like you would draw any other force diagram for joint 1. Ah yes, these two angles here will add together inside that angle there, just from your geometry rules. And then from that being the isosceles triangle, those two angles will be 20 degrees. Now we can just use the sine rule to find out the force in AD or BD. It doesn't matter, because it's isosceles, so it's going to be the same, but in the other direction. And since we now know 2 of the 3 forces in these members, we only have to get one more of them. So we're just going to look at any joint, doesn't matter. So we'll pick joint 2. This one, we're just going to draw our forces in. One we know about, 250 newtons. Then we're just going to project these two lines here. 266 from what we've done before, then X. And we just use Pythagoras to work that one out. So there we have our answer. Summing up, first you draw the reactions, then make a free body diagram, then label all the joints in the areas, then you have to analyze each member with their own free body diagram, and draw force diagrams when you need to find the forces graphically or analytically. It's your choice. Coming up next, we'll look at the method of sections. Good luck with your studies.